Welcome back again, solving numerical problems for medical entrance examination, JEE Main and Advanced. This time again, a problem from refraction in a prism. We'll derive a general expression. Now look at the statement. Light falls at grazing incidence on one of the surfaces of a prism. So if you look at the diagram, your A, B, C is a glass prism of refractive index mu2. I'll take it as mu, surrounded by AR on this side and AR on this side. Mu1 is equal to 1, mu1 is equal to 1 for air or vacuum. This is one of the refracting surface AB, AC is another refracting surface, and PQ is the incident ray, because grazing incidence means, therefore this angle of incidence here I is equal to 90 degree. So it was supposed to move to this side. So going from rarer to denser, it bends towards the normal. So this is your angle of refraction R1 at the point R. At the point R, it was trying to move to this side, going from denser to rarer. This is the amount by which it has bent. Let it be delta 2. And I have told you in previous videos, if either this is 90 or this E is equal to 90, then the deviation becomes maximum. But here we are deriving something else. The refractive index is mu and angle is A, so that the angle of emergence is given by sine E is equal to mu square minus 1 square root of that sine A minus cos A. This is a general expression. So this is a general problem. So since angle of incidence here in the rarer medium is 90, therefore I have to call this R1 as the critical angle. Means if light travels from this side, it will move to this side, making this as 90 in the rarer medium. So this will be called the critical angle. So R1 is called the critical angle. I will represent it as angle C. And for a prism and for a glass prism, it is always true that this angle A is always equal to R1 plus R2. So since A is always equal to R1 plus R2, so R2 is equal to A minus R1. And since R1 is the critical angle, and I have used a new symbol for critical angle as C, therefore R2 is equal to A minus C. Not this point. This angle I am taking as C. So now let us go to the point R. Here, if you apply Snell's law, coming from this side, this is your angle of incidence. So this will be your angle of refraction R2. So sine E over sine R2 will be mu2 over mu1. So sine E over sine R2 will be mu2 over mu1. Since mu1 is a rarer medium, that is I have taken as air or vacuum. So for mu1 I put 1, for mu2 I put mu. So mu1 over 1 is mu. Now look, now if you cross multiply, your sine E becomes mu times sine R2, and sine R2 I just explained how this R2 is equal to A minus C. So for R2 I put A minus C. So sine E is equal to mu times sine A minus C. Sine A minus B, formula in trigonometry identity. So becomes mu times sine A cos C minus cos A sine C is equation 1. Keep this sine A and cos A intact. Don't change it. We'll change cos C and sine C. We'll change cos C and sine C only. So since we know 1 by sine C is mu, because here if this is the critical angle, sine 90 over sine C will be mu 2, that is mu over 1, that is mu. That is 1 by sine C. 1 by sine C is mu. So sine C is 1 by mu. So how to get cos C from sine C? Cos C will be 1 minus sine square C square root of that. That is cos theta is 1 minus sine square theta square root of that. Now put the value of sine square C here. Take LCM. So it becomes square root of mu square minus 1 over mu. So your cos C is found out, your sine C is found out, and put this value of sine C and cos C in equation 1. So your sine E now reduces to mu times sine A cos C minus cos A sine C. Now if you take mu common from here, which is in the denominator, if you take common outside the bracket, this will cancel with this, so we'll be left with sine E only. So it will be sine A times mu square minus 1 square root of that minus cos A because this mu have been taken common and has been cancelled with this. So sine E is equal to mu square minus 1 square root of that times sine A minus cos A. So this is a general expression for the angle of emergence, when on one side the angle of incidence is the grazing angle of incidence. So for grazing angle of incidence and angle of the prism A and refractive index of the prism mu, the angle of emergence will be given by this, means E will be sine inverse of this. This is a general expression, so you can use it. If you know mu and A. By straight way using this, you can find out the angle of emergence. So this is a general one, it's a good one. Okay, thank you.